The next example, use Newton-Raphson method to solve the equation x raised to power 6 minus 3x raised to power 4 plus 2x squared minus 3 is equals to 0 near x is equals to 2.2. So when you are told the near x equals 2.2, meaning this will be starting your x naught, isn't it? Are we together? So you'll be told to use the Newton-Raphson's method to solve the equation x raised to power 6 minus 3x raised to power 4 plus 2x squared minus 3 is equals to 0 near x is equals to 2.2. So the first thing you know is what? You know is that f of x is equals to 0. The root of the function exists when the function is equals to 0, isn't it? So the equation we've been given is x raised to power 6 minus 3x raised to power 4 plus 2x squared minus 3 is equals to 0. So the two equations are equals to 0, meaning f of x is equals to this, isn't it? So the function is what? So the function of x is equals to what? X raised to power 6 minus 3x raised to power 4. Are we together? Are we together? Then it is plus 2x squared minus 3. Meaning the function, you must ensure that the equation is equals to 0 is when you can get the function. Are we together? When there's something on this side other than 0, you have to remove it by bringing it on this other side, isn't it? Are we together? The function, you will only get the function when the equation is equals to 0. There must be 0 on the other side, okay? So we found the function from the equation, isn't it? Having found the function, what do? We differentiate the function, isn't it? So when we differentiate the function, f prime of x, what do you get? When you differentiate x raised to power 6, 6 times 1, you get 6, then you reduce the power by 1. 6x raised to power 5, isn't it? Then here, 4 times negative 3, x cubed, you reduce the power by 1, isn't it? Then this, 2 times 2 plus 4x, isn't it? Are we together? Yes. Then when you differentiate a constant, you get 0. Now after getting the function and the derivative of the function, so we want to use iteration, meaning we now substitute x with xn, isn't it? Yes. Are we together? Yes. So where there is x, we put xn now, isn't it? So anywhere you see x, put n in it, xn, xn, xn. F prime of xn, 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 xn. So you found f of xn and f prime of xn. Because the equation is giving you f of x. And from f of x you get f prime of x. It's when you put your n for the iterations, isn't it? Is that okay? Yes. Now having found the iterative function and its derivative, we now write the Newton-Raphson's method, isn't it? In the Newton-Raphson's method we have what? Xn plus 1 is equals to xn minus the function over. After the function, you differentiate the function, you get f prime of x. Then you put your n's. Are we together? Is that okay? So this is the Newton-Raphson's method. So how do we simplify it? The LCM, isn't it? The LCM, meaning this is over 1. So if you look for the LCM, what do you have? What do you have? 1 times f prime of xn. So you get f prime of xn. Then so you just cross multiply this times this, isn't it? This times this, you get xn times f prime of xn. When you say 1 goes here, f prime of x times 1, isn't it? Then we have subtraction in between. Then minus f prime goes here, 1s times this, or it is simply that times that, cross multiplication, isn't it? You get minus f of xn, cross multiplication. This times this gives you that, then minus it between them, this times this gives you that, then over this times this gives you that, isn't it? You can only do cross multiplication when you have 2 terms only, isn't it? Are we together? Yes. Only when you have 2 terms is when you can do the cross multiplication of fractions, isn't it? Yes. So Having found this, meaning the next step we do what? We substitute, isn't it? So xn times f prime of xn, so when I'm substituting the value of f prime of xn, I have to put it inside bracket to show one thing, isn't it? So put it inside bracket. What is the value of f prime of xn? Go back. What did you get? What was this value? 6 xn raised to power 5 minus xn cubed, isn't it? Then plus, then you are done. So the whole of that bracket is f prime of xn, isn't it? Then it is minus. It is minus what? F of xn, isn't it? So what is f of xn? Xn raised to power 6 minus 3 xn raised to power plus 2 xn squared minus 3. So you substitute everything. Anything you are substituting must be inside the bracket to show that the whole of this is f prime of xn, the whole of this is f of xn. That's why it is in bracket to show one thing, isn't it? Then it is all over f prime of xn, isn't it? And your f prime of xn is what? 6 xn raised to power 5 minus raised to power 3 plus 4 xn. See, the next thing is now to open the brackets, isn't it? What is outside multiplies everything inside, isn't it? So what do we have there? Xn times xn raised to power 5. So we have 6 xn raised to power xn times raised to power 5. So you get 6 laws of indices, same base and multiplication sign, you add the powers, isn't it? Yes. So xn raised to power 6, xn times xn raised cube, you get minus 12 xn raised to power, because it is cubed and you are adding, you are multiplying by 1 more, it is raised to power 4 now, isn't it? Then the other one plus 4 xn times 4xn squared, isn't it? Are we together? So you have opened the first bracket. Go to the second one. Negative multiplies everything inside that bracket, isn't it? So we have minus xn raised to power 6. Then negative into negative plus 3 xn raised to power 4. Negative into positive negative 2 xn squared. Then negative into negative plus 3, isn't it? Then everything is over. Everything is over. 6 xn to power 5 minus 12 xn cubed plus 4 xn. See, the next thing you now do, so you see this one is equals to, this was xn plus 1 on this side of the equation, isn't it? So you just simplify it. Are we together? You just simplify it. So if you simplify it, you will get xn plus 1 to be equals to, start with the ones with power 6. See, this is 6 xn to power 6, this is minus xn to power 6. How many you remember? See, there's a silent 1 here. Yes. Yes, so 6 minus 1, you get 5 of them, isn't it? Are we together? If you say this x raised to power xn raised to power 6 is 8, so it's like 6a minus 8, so you get 5a. Are we together? So you have 5 xn raised to power 6. So you take what you dealt with, you move to the next one. Xn raised to power 4, isn't it? So here is negative 12 and here is positive 3. What do you get? Negative 12 plus 3. You get negative 9. So if you simplify that, you get negative 9 xn raised to power. Are we together? Tuko pamoja? You are done with that. Move to the next one. The next one is, here we have 4, positive 4 xn squared, and here we have negative 2 xn squared. What do you get? Positive 1, negative 2 gives you positive 2, isn't it? So you get 2 xn squared. You are done with that. What is left? Remember, what you've not taken is what is left. What is left is plus 3. So you simplify the numerator, isn't it? Are we together? Yes, you've joined this and this, you've gotten 5 xn raised to power 6, you've joined this and that and that, you get negative 9 xn raised to power 4, You join this and this, you get positive 2xn squared, isn't it? Then plus your 3. Are we together? Then it is over. It is over 6. Xn to power 5 minus 12 of xn cube plus 4xn, isn't it? So now our xn plus 1, where there is xn, you put your answer, isn't it? You put your answer. So what are we going to have? 5 answer raised to power 6 minus 9 answer raised to power. Remember, xn is the answer, so this is answer raised to power 4. This is answer raised to power 6, isn't it? Xn is the answer. This is answer squared, isn't it? Plus 2 answer. Yes, squared. Then the plus 3. Then in the numerator you have 6 answer. Answer raised to power 5 minus 12. Answer raised to power 3 plus answer. Are we together? Xn is the answer. So this is answer squared, answer raised to power 4, answer raised to power 6, answer raised to power 5, answer raised to power 3, answer raised to power 1. Just answer, isn't it? Are we together? Yes, so if you're using that calculator, you know how to put it, isn't it? The numerator, you open the bracket, then inside the bracket you have 5 answer raised to power 6. Then minus 9 answer raised to power 4. Then plus 2 answer raised to power 2. Then plus 3, then you close the bracket for the whole numerator. Are we together? So you fed the numerator, then you put divide by, then you open the bracket of the denominator. Then you start again. 6 answer raised to power 5. Minus 12 answer raised to power 3. Then plus 4 answer. So you have numerator divided by denominator. Are we together? So, once you have this, we now want to start. Where have you been told to find the root? Near x is equals to 2 point? And to how many decimal places? So if you are not told, you can choose the number of decimal places, but not less than 4 decimal places, isn't it? So before you feed the answer in the calculator, the first thing is to fix the number of decimal places. Are we together? Can we fix maybe how many? 4 decimal places. 4, isn't it? So go to shift and go to setup. If you're using the other calculator, then under setup you go to fix 4 decimal places, isn't it? Are we together? Your calculator, you just go to mode direct and you get the fix, isn't it? So after getting fixed, it will tell you between 0 and 9 decimal places, how many do you want? You want 4, so you fixed 4 decimal places. We are done there, isn't it? Then after done there, the next thing to do is what? The first value. What were you told to get near x is equals to 2.2? Meaning what? X naught is equals to 2 point. So press 2.2 is equals to 2.2. Then feed the formula. Or if you fed the formula, you just replace, isn't it? You've already fed the formula. Yes, after that is equals to 2. What you do, if you want to minimize it, you can start feeding the pool immediately. It does not matter. Or if you want to minimize it, you press the AC button, not the on button. The on button will erase everything. Are you seeing? The AC button minimizes the screen. Are we together? Minimizes what is there, the display. So feed the formula after that. You've pressed x not equals 2.2. Now feed the formula. You've already fed it. You know you can start with anything. You can either start with this or this, isn't it? Because you can always replay back, isn't it? I feed the formula in the numerator. Put the, if you are using that calculator, press the fraction button. After pressing the fraction button, start feeding the numerator. So the numerator, we have 5. Then you put for us there answer squared. There's that cube for putting the power. No, it is answer raised to power 6. Isn't it? Then it is minus 9. Answer raised to power 4. You are feeding the calculator in case of that calculator. Then plus 2, answer raised to power 2. Then plus 3, you are done with the numerator. Go to the denominator, do the same thing. Feed the formula, I want to see. So there you have answer raised to power. So you can see this one, x raised to power, that, answer raised to power 6. then you press this to move forward. Then minus 9 answer raised to power 4. Move forward. You cannot press plus if you not move forward. Yes. We did. Move forward. This is what means you are moving forward to the next line. This, first of all, put the fraction, then fill the numerator. So the power is this, x raised to power anything. So x is your answer, you see. So which one are you feeding there in the first one? 5 answer, then raised to power. Fill that power 6, then you press this to move forward. Yeah. Then you have see, you move back and see. Plus 2, answer square. See, then it is plus. Yes, you just replace to go back to the numerator, go back to the numerator, go back to the numerator, does not matter. Yes, plus 3. Then we scroll down. Delete those. No, if you want to go to the denominator, if you want to delete it, see, you move forward to delete it from front 1. Delete it. Yes. There? Have you fed? Yes. Have you fed? Yes. So once you fed the formula, it will give you the first answer, isn't it? Yes. See, you now, this is x naught is 2.2. Now, if you are getting x1, you can just press an AC button to minimize the formula. Press an AC button to minimize the formula. Press an AC button to minimize the formula. Then feed the first value again to confirm. 2.2 is equals to 2.2. Then replay. There are those buttons. Replay back. There are those buttons for replay. Replay back to get until you see that formula. Have you pressed the replay? The upper key. Yeah. Once you see the formula, you press equals to see if the answer you found is the same. Is it giving you the same value? So it means you have to confirm it twice, isn't it? To see if that value is the same. You've confirmed it. So what you fed the formula, you start at 2.2. So for us to get x1, what do you have? First 2.2 is equals to 2.2. Then you replay back the formula is equals to what? What do you have? (2.2) is equals to 2.2. Then if you feed that, you get 5 answer raised to power. No, you place answer on top. I told you you must move forward. Look at this. You place the value on top. Using it is on top of, and you have to move forward and put it down there. Can you see that? You place it in form of a power. So what have you found to be x1? 1.9? 1.9? 3? 1.9383. Then you move x2. You just continue pressing equal sign now. After 1.9383, you get the first that, then you just continue pressing the equal sign. 1.7? 585. If you press equal sign again, you get x3. What do you have?
1.6632.
1.6632. If you press equal sign, you get x4. What do you get? 1.6345. If you press equal sign again, what do you get? 1.6345. Meaning it has repeated itself, meaning that is there, isn't it? Meaning if you continue pressing it, you'll be getting the same thing, isn't it? So it means that is where the root is. So it means our x, the root, is 1.634. Is 1.63445. Are we together? 1.6345. And you would have solved that problem.